Welcome back to another video. Today we are going to use the principle of mathematical induction to prove that if a1, a2, a3 all the way to an and b are integers such that the greatest common divisor of a1b equals the greatest common divisor of a2b and equal to all the way to the last one, which is the greatest common divisor of a and b equals 1, then the greatest common divisor of a1, a2, a3 all the way to an and b equals 1. Okay, so I'm going to use the first principle, mathematical induction, which is that you have to let Pn to be the statement with positive integer n and try to show that P1 is true, which is the base step. So the first thing you have to do is to show that the base step is true. And then the second step is inductive step, which is to assume that P of k is true, then try to show that P of k plus 1 is true. Then once you have the base step and inductive step, you have shown that the statement with Pn here is true for all positive integer n. And then I'm going to try to use theorem 2.4.7, and especially with the first property, which is if the greatest common divisor of am equals the greatest common divisor of bm equals to 1, then the greatest common divisor of AB and M equals 1. As you can see, the second number right here are the same. Okay. Now let's prove it. Let's use a proof by. Let's use a proof by the first principle of mathematical induction. Now, the first thing I'm going to do is to let assume this assumption. So we gotta let a1, a2, a3 all the way to an and b be integers such that the greatest common divisor of a1b equal a2b equal all the way to a and b equal 1. And then I gotta let p of n be this statement. The greatest common divisor of a1, a2, the greatest common divisor of a1, a2, a3 times all the way to an and b equals 1. Now let's start with the base step. Now what's going on with the base step? I want to start with the case where n is 1. So I gotta let a1 and b be integers such that, so actually we might start with just this, right? Because I let a1, a2, a3 all the way to an and b be integers such that with this condition. So now for the first step, I think we gotta have the greatest common divisor of a1b being 1 already, right? Which is by assumption. Okay, so by assumption, this equation is true by assumption. Okay, by the assumption. So P1 is true, right? P1 is true. Okay, so what about P2? Okay, P2. I just want to have P2 because we have to assume that A1, B1 equal to 1 and greatest common divisor of A2, B equal 1. Okay, so from this right here, what do we have? We are going to use theorem 2.4.7 and the first property. Then what do we have here? We gotta have. So we gotta write by theorem 2.4.71. Okay. What happened? The greatest common divisor of A1, A2, B will be just 1. Just like that. Okay. So P2 is true. Okay. P2 is true. So I think that's it for the base step. Now let's go to inductive step. For inductive step, let's assume that. So assume that PK is true. Okay. Is true for every positive integer k. Okay. Then try to show that P of k plus 1 is true. Okay. Try to show that P of k plus 1 is true. But what do we have right here? We have that P of k is true for every positive integer n, right? So what do we have? So since pk is true, what happened? What do we have here is the greatest common divisor of a1, a2, a3 all the way to ak and b equal 1. So if you want to have pk plus 1, which is true, so we have to assume that. So we have to assume that the greatest common divisor of ak plus 1b equal 1. We need to have this, right? Okay. So now, since we have this term right here, okay, this is from pk, and the greatest common divisor of ak plus 1 and b equal 1, then what do we have? So theorem 2.4.7, the first property. What does it imply? It implies that, okay, it implies that a1, a2, a3 all the way to ak times which one? ak plus 1. Okay, ak plus 1b, and it turns out to be just 1. Okay, it turns out to be just 1. So hence we have shown that. Hence P of k plus 1 is true. Okay, so now we have proved the inductive step. So therefore, the first principle of mathematical induction has proved that if a1, a2, a1, a2, a3, all the way to an and b are integers such that the greatest common divisor of a1b equal a2b equal a3b and all the way to a and b equal 1, then the greatest common divisor of what? a1, a2, a3 all the way to a, n, and b equal 1. Okay. So we have proved problem 5 already, and that's it for this video.